Good morning, students. This is class 11th physics. We are doing chapter 10, mechanical properties of fluid. So, fluid, what are fluids? So, any substance which can flow when an external force is applied on it, they can be termed as fluids. So, liquids and gases can flow. So, these are fluids. Now, why do we need to study fluids? Children, fluids are everywhere around us. Earth has an envelope of air, that is atmosphere, and Earth has 2/3 of its surface covered with water, which again is a fluid. Water, children, it is not only necessary for our existence, but every mammalian is surviving due to water. Our body, it constitutes of water. All the processes occurring in the living beings, including plants, are all mediated by water. Therefore, children, it becomes very important to understand the behavior and properties of fluids. Right. So matter, we can classify them into two parts. First is solids and others are fluids. Solids, as we know, it has fixed shape and it cannot flow. But under fluids, we can categorize as liquids and gases. Liquids, they have fixed volume, but that is not case with the gases. Gases have no fixed volume and they are highly compressible. Now this fluids, children, if we apply shear stress on it, we have studied in the previous class, shear stress when we apply, it changes the shape of the object, right? We saw there that when we are applying the shear stress on the solid, the shape of the object changed, but its volume remained fixed. But think about if you apply the shear stress on fluids, then its shape will change very easily, right children? Because the resistance which the fluid offers to the shear stress is very little. So shear stress of fluids is about million times smaller than that of solid. So solid, if you apply shear stress, uska shape change hoga, shape will change, but its volume will be fixed. But that is not the case with the fluids. Right, so this is your introduction. So in this chapter, we are going to study about hydrostatics and hydrodynamics. Statics means at rest. So under hydrostatics, we are going to study the fluids which are at rest. And under hydrodynamics, dynamics is motion. So we are going to study the fluids which are in motion. So for describing the fluids, children, we require some basic quantities. So first quantity is pressure. So pressure we know it is the force exerted per unit area. So force upon area is your pressure. Here we have taken an example that if you are applying the force by a thumb on the thumb pin, then equal and opposite reaction force will be exerted according to Newton's third law of motion. But our thumb does not get hurt, does not get injured. Why? Let's see. Here, children, this area of this pin, we have assumed it to be 0.01 millimeter square, right? Area of the tip of the thumb pin, and area of the head of the thumb pin is 1 centimeter square. Let's calculate the pressure. Pressure on the thumb is force. Force is equal. If you apply with the thumb 100 Newton force, then equal force will be exerted as a reaction force, right children? So 100 Newton. But what's the area? Area is centimeter square, 1 centimeter square, which is 10 to the power minus 4 meter square. So if you calculate, minus 4 will go up and it will become 4 and 2, that is 10 to the power 6 Newton per meter square. This is the pressure exerted on the thumb. Now let's see the pressure exerted by this tip of the thumb pin on the board, right? Now here the force is same 100 Newton, but the area, if we convert this 0.01 millimeter square into meters square, then it will be 0.01 into 10 to the power minus 6. Now this goes up and you are going to get 10,000 into 10 to the power 10 to the power 6. So 10 to the power 6, right? Same. But the pressure on the board is about 10,000 times more than the pressure on the thumb. And so because of this reason, the pin, it gets inserted into the board and the other end of the pin does not get inserted in our thumb, right? So let's learn a little bit more about pressure. If we talk about pressure in fluids, now children, whenever a liquid is in equilibrium, means liquid is not moving, because this is the part of the chapter in which we are studying about the fluids at rest. So here the fluid is at rest. So whenever the fluid is not moving under that condition, so here you can see the object is submerged in a liquid which is at rest. So children, this liquid will exert a force on the object, on the surface of the object in normal direction, that is perpendicular to it. Right. Agar aap bolo, no ma'am, there might be some force like this. So children, suppose this is some force. If we say this is one force, then we can resolve it into two components. That is, suppose this angle is theta, then just a second, let me draw it bigger. Suppose we say that there is some force acting like this. Then this force, we can resolve it into two components. First is your x component and other is your y component. Suppose the angle over here is theta. So this is your f cos theta and this is your f sin theta. But as children, the fluid is not moving. So the f cos theta will be equal to 0. F cos theta will be equal to 0 because the object is also not moving horizontally. Left right object move nahi kar raha. It means f cos theta 0 hoga, right? F cos theta is 0. It does not mean force is 0. Force is always acting, right? Force is there. It means that cos theta is 0. Now children, we know for theta equal to 90 degree, cos value is 0. It means that force is acting but at an angle of 90 degree. Means when a liquid is in equilibrium, the liquid, the fluid will exert a force on the substance which is inside it, which is submerged in it, but always at 90 degree to the surface of the object. Right children? So be very careful. That force is known as upthrust. That force is known as upthrust. So we know pressure is force upon area, but which force? That is normal force, normal to the surface. Normal is 90 degree, right? So here we are having a device, simple device, which is used to measure the pressure, the hydrostatic pressure, the pressure of the fluid which is at rest. So here we are having a setup that this is some chamber C, and inside the chamber you are having a spring S, and inside the chamber you have created vacuum, right children? Now the spring, it has the spring constant K. Now you are going to place this device into this beaker. You're going to put this device over here. Why? Because you want to measure the pressure exerted by this fluid. So this is a device which will measure the pressure. वो pressure नापेगी कितना pressure है इस fluid में. So what will happen? The fluid will exert a force F on the piston. This red, this is your orange color is the piston, right? You have seen the piston in the syringe, right? Injection syringe, right? So because of the force exerted by the liquid, the piston will move downwards. As the piston moves downwards, spring will get compressed, beta? Yes, spring compress ho jayegi, and now the restoring force of the spring comes into action. वो spring के अंदर एक force generate होगा और spring will try to get back to its original position. वापस वो अपनी original position में आएगी. तो वो क्या करेगी? Piston को बाहर की तरफ धक्का लगाएगी. So at equilibrium, what will happen is the pressure at equilibrium, pressure which is equals to force upon area will be equal to kx upon A, where K is the spring constant and X is the displacement, or X is the distance moved by the spring, or X is the compression of the spring. So by this, children, we can measure the pressure inside the fluid. Now we know pressure is a scalar quantity. Its SI unit, force SI unit is Newton, area is meter square, so it is Newton per meter square, which is also known as Pascal in the honor of a scientist, that is Blaise Pascal. Right, beta? Its dimensional formula, we know it is m1, L minus 1, T minus 2. Now, a very common unit of pressure is there, beta, which is used to measure the pressure of the atmosphere. That is ATM. So this is the atmospheric pressure, or this is the pressure exerted by the atmosphere at the sea level. At the sea, the atmosphere is exerting that pressure. That is this pressure. So 1 atmosphere is equals to 1.013 into 10 to the power 5 Pascal. Very, very important value. You need to remember this value. Now, another quantity which is very important when we are going to describe the fluids, when we are going to study the fluids in detail, is density. Right? Now, for a fluid whose mass is m and occupying the volume v, its density will be given by mass upon volume. Density, we know it's a scalar quantity. Its unit will be mass ka unit kg, volume is meter cube, so it is kg per meter cube. And the dimensional formula will be m1 and L minus 3, right? This is simple. Now here we need to remember one value which we had done in class 10th also, that is the density of water at 4 degrees centigrade is 1000 kg per centimeter cube. 1000 kg per centimeter cube hoti hai density of water. And if you convert it in terms of grams, it will be 1 gram per centimeter cube, right? Another small term that we need to know is relative density. This also we know it is a ratio of the density of the two substances, right? But here if we take, instead of another substance, if we take the density of water, if the reference liquid, we take it as density of water, then we will call it as specific gravity. Okay, means suppose I am talking about aluminium. So density of aluminium upon density of water. So नीचे water आ गया. If you are comparing it with water, then you will not call it a relative density. You can call it as specific gravity. Right, beta? And as it is the ratio of density, it is a unitless, it is a dimensionless quantity. Now, if we say that the aluminium specific gravity or relative density is 2.7, what does it mean? It means that you have taken the ratio of density of aluminium upon density of water. So it comes out to be 2.7. So if we say that the relative density of aluminium or the specific gravity of aluminium is 2.7, it means its density is 2.7 into 10 to the power 3 kg per meter cube. Right, children? Now, very important, Pascal's law. Very important, Pascal's law. Now, children, the scientist Blaise Pascal, he observed that the pressure in a fluid which is at rest is same at all the points if they are at the same height. What does it mean? Suppose I am having a bottle over here. Just a second. Suppose I am having a container over here, and at this height, suppose the height is 3 centimeters from the base. At this height, if I see the pressure at yellow point, the pressure at green point, the pressure at blue point. He is saying that the pressure at yellow point, green point and blue point is same as they are at an equal height of 3 centimeter from the base, right? Means at equal height, at same height, the pressure in a fluid which is at rest, the fluid should be at rest, is same. Now let's try to prove this law, Pascal's law. So here Mr. Pascal is drinking some fluid, right? Now we have taken a very small portion from the glass and we have zoomed it, and that is this portion, right? Now inside this portion we are going to assume a element, that is this 3D element. Here you can see this 3D element. Okay, इसमें एक छोटा सा element we are assuming. This is not that we are putting a object over here. This is not object. This is water only. In water only we have created shape with water, right? So here you are having an element, and the element is A, B. This element is A, B, C, and the back part of the element is, this top is D. Here it is F, right children? And this point is E. So the front triangle is ABC and the back triangle is DEF. I hope this is clear. So this is your water element which we have considered, right? Now, here we are supposing that the force, now we are going to just, that is we are viewing the element that is ABC. 3D हम कर सकते हैं, but it is simple for us to go for 2D. So we will prove it with that. Now the force that is acting on this BC phase is FA. The force that is acting on this AB phase is FC. The force that is acting on AC phase is FB. Right, beta? But you will say that, ma'am, we will have mg, that is the weight, that is also a force, that also should be acting. Yes, why not? That will be acting. But again, children, we are going to ignore it. But even if we consider, then again it will be equal for all. And hence, finally, it is going to cancel out. Right? So we are leaving mg for the time being, and we are calculating the pressure at the faces, that is AB, BC and AC. If we talk about 3D phase के बारे में अगर बात करें तो यही वाला जो rectangle, ये वाला जो rectangle बनेगा, this rectangle, that is your A, B, D, E. Right, वो वाला face उस तरफ का, right? 3D में देखो तो. So we will see that the pressure on the three faces, they are equal, means PA is equal to PB equals to PC, right? That we need to prove. Now let's see how. Now what we are doing here it is capital B. So this side we are putting the force as FB. Right, this side we have named it as A. So opposite to this we will say that the force acting is FA and the pressure is PA. This is what I see. So opposite to this we will say, on opposite to see this, the force is FC and the pressure is PC. I hope this much is clear. Right, these are the forces FA, FB and FC. They are the forces which are acting normally to the surface. AB के normal ये force लग रहा है 90 डिग्री पे, BC के normal 90 डिग्री पे FA force लग रहा है, and AC के normal at 90 degree FB force लग रहा है. So this is all normal forces which we have considered. Right, beta? Now, so if we make a diagram for this, so children see, this is your FC. So see, this is our FC, right? This is FB, sorry, FA. So this is our FA. No problem in this. Now, this direction is FB. So this is my FB, right children? Now I can resolve Now I can resolve FB into its components, right? I can resolve FB into its components. Now, here the angle that is theta 1 is the angle made by FB with FC. तो देखो FC और FB के बीच का angle हो गया theta 1 बेटा. Similarly, if you see over here theta 2 is the angle between FB and FA. FB and FA, that is theta 2. So this is theta 2, right children? So here this will be F, if we think in terms of theta 2. ठीक है, यहाँ पे हम theta 2 के terms में लेंगे, then this is FB sin theta 2, right? This is FB sin theta 2, right? And this will be FB cos theta 2. FB cos theta 2 हो जाएगा, but इसको हम FB sin theta 1 भी तो लिख सकते हैं because this angle is theta 1. ठीक है, तो उसके जो y component होगा that will be FB sin theta 1, right? But you can write it as FB cos theta 2 also, no problem in that. But we know that it is FB sin theta 1. I hope this much is clear. Now, as the liquid is at rest, can we say that FC is equal to FB sin theta 2? They are opposite to each other. As the object is not moving, as the liquid is at rest, fluid is at rest, means the forces, left force will be equal to right force. Up force will be equal to down force, right? Because it is at equilibrium, it is not moving. So children, here FC will be equal to FB sin theta 2 and FA will be equal to FB sin theta 1. So let's write it. So FA is equals to FB sin theta 1 and FC is equals to FB sin theta 2. Right, beta? Now, let us define that the area of this BC is area for A and suffix में A लगाया, ठीक है? And the area of this face is AB and the area of the face, this third face is AC. So here also children you can write, if in this triangle, if you find out sine theta 1, then you can write sine theta 1 equals to opposite. What is opposite? AA upon hypotenuse. What is hypotenuse? Hypotenuse is AB. तो देखो बेटा ये आ गया ना, AA equals to AB sin theta 1, right? Similarly, you will get AC equals to AB sin theta 2. Now what you need to do, simple, you are just going to divide these equations. When you divide this 2 and this 2, so what will happen? You are going to get FA upon AA equals to FB sin theta 1 upon AB sin theta 1. Sin theta 1, sin theta 1 cancel. You are having FB AB, which is equals to FB AB क्या होगा? PB, pressure, force upon area, right? Similarly, अगर आप इन दोनों को divide करें बेटा, इन दोनों को divide करें, यहाँ पे आएगा FC upon AC, that is what? PC. Sin theta 2 cancel, FB upon AB, that is PB. So PC is equals to PB, AB equals to PB, means AB is equal to PB equal to PC, right? So pressure at A, PA is equals to PB equals to PC, means pressure exerted is same. PA is equals to PB equals to PC in all the directions in a fluid at rest. So pressure, you can see, if the fluid is at rest, then the pressure at all the faces is the same. So this is your Pascal's law. Now, if you talk about horizontal plane, so this is your horizontal plane. So inside this, the pressure is going to be same at all the points because children, it is at same height. It is horizontally, so it is at same height from any reference point. Suppose you take this reference point. So from here the pressure at each and every point will be same inside this horizontal plane, because the horizontal plane is at the same height from the reference point. So the pressure will be same at all the points.